Right, so we're going to talk about Maclaurin series expansion in this lesson, okay? And do note that we won't be talking about the proof, okay? So we'll just take it as is. This is actually the general formula for Maclaurin series expansion, okay? And in this lesson, I'm going to teach you how to do it, okay? How to use the Maclaurin series expansion, okay? To come up with the expression for any fx that is given in your exam question, okay? Now, the thing is, before we continue this, I just want to talk about some notation over here, because sometimes, I realize that some students are still not quite familiar with this, okay? So I want to talk a little bit about this. Now, ignore the zero because I just want to leave it general so that we will just talk about f prime x, okay? So I guess for most of you, you actually know that f prime x is actually the derivative of fx. So d dx, okay, fx is actually equals to f prime x, okay? So this is just some basics, all right? So going off a little tangent off from Maclaurin series because I just want to talk about this, just make sure that you guys know about this, all right? I'll make it quick, okay? So if you were to differentiate this guy again, like if you differentiate f prime x again, that's going to give you f double prime x, okay? So on and so forth, right? So some of you may be quite familiar with these notations. So when you have y equals to fx, then when you differentiate it, you can call this dy dx d2y dx squared. And then again, when you have f triple prime x, this is actually d3y dx cube, okay? So these are the higher order derivatives, okay? Now, the thing is, what happens when you have f prime 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 prime, which is d4y dx4, x to the power 4, right? So that one, we will write it as a bracket 4 and then x, okay? So notice that there's a bracket 4, okay? Because when you have so many of those primes, okay, it's getting a little bit difficult to count, right? For example, the one over here. So the thing is, usually we would use it up to about here, 3, and then anything after that we put a bracket. And it is important to remember that you must put a bracket, okay? And this means d4y dx to the power 4, okay? And so on and so forth. So I could say f 2000, okay, is just to exaggerate a little bit. That means that you are going to differentiate fx, okay, 2000 times, all right, and get an expression. Usually by then it would have been 0, but okay, just for illustration, all right? So this is differentiation. Now, there is a difference, okay? If you happen to write f4x, this would be different from f bracket 4, okay? So like I said, this means d4y dx4. This one is actually in the topic of functions. It's completely different. It means that we will have a function where we place fx, okay, within fx, within fx, within fx. Okay, I'm scribbling down here. All right, so there is actually 4 f's. So in other words, if you were to study function, this means f, 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 x. All right? Okay, it's different, okay? So be careful of the notation down here, all right? When you see f4 and f bracket 4, they mean different things, okay? Now, with that squared away, let's talk very simply and in general, okay, how to use the Maclaurin series expansion, okay? And then in the next video lesson, I'm going to use an example and show you how to achieve the steps we are going to talk about over here, all right? But let's keep things general first. So, first thing first, step number 1, what you will do, okay, when you are given a particular fx, right? They tell you that you have this fx. What you need to do, first thing first, is to go ahead and figure out all the derivatives, okay? So depending, listen carefully over here, depending on the question, they will usually tell you up to the powers that they want. So if they say that, okay, I want you to derive the expansion, okay, using this formula up to and including x cubed, then in that case you would need to do up to f triple prime x, okay? As you can see, notice the pattern over here. When you have x is f prime, and when you have x squared is f double prime, x cubed is f triple prime. So if you want x to the power 4, then you would have to do up to f for x, for example. Okay, all right. So what you need to do is to go ahead and differentiate, okay, multiple times until you get to the required power that you want. All right. So if it's x cubed, just stop at f triple x. Okay. Now, once you have all this expression, what we're going to do now in step number 2, okay, is to sub x equal to 0 into all these, okay, into the derivatives in step 1, okay? So that means you're going to obtain f0, f prime 0, okay, f double prime 0, f triple prime 0. Okay, I'm going to put a dot 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 just to, let you know that you can continue or omit some of the terms depending on what the question was, right? So I'm actually following a case whereby we wanted to include the term up to x cubed, okay? Now once that's done, we're going to move on to step number 3, okay? And that is to sub, okay, the values in step 2, okay? In step 2 into the Maclaurin, okay, series expansion formula. So as you can see, over here we have f0, we have the value of f prime 0, we have the value of f double prime 0, we have the value of f triple prime 0. So just go ahead and sub those in and then simplify the expression, okay, if required, and then you will have the answer, okay? You will have the series expansion for the fx that is given in your exam question. All right?